Hello, can you hear me? Okay, great. If you guys can hear me, then I can start the session. Uh, okay, uh, let's start with what is artificial intelligence. Like in this session, I'll go through multiple things like um, what is artificial intelligence and what is machine learning, and finally, we will learn about how to get started in this domain and what are the different career opportunities you can go through in this domain. So this will be in this series, like what is artificial intelligence and its applications, and then next you learn about machine learning and bit depth about how machine learning works, and then you will learn about how to get started in this domain, and then finally you will learn about what are the different career opportunities uh, you can pursue in in this domain. So let's start without wasting any time. Let's get started. So, first learning about something, we need to learn about the history of that one. So, I'll start with what is the history of AI. If you don't know anything, I'll just give a small introduction to what is the history of AI. So, it started in 1950, where the English mathematician Alan Turing. I think if you're a computer science guy, you'll definitely know about Alan Turing. If not, definitely you need to check about him. So he wrote a landmark paper titled Computing Machinery and Intelligence. So in that paper, he asked the question like, can machines think? So with this question, the complete industry was talking about this question. Can really machines think? And everyone started doing research and publishing multiple papers. And then in finally in 1956, it was John McCarthy who coined the term officially. Like he coined the term artificial intelligence officially at the famous Dartmouth workshop with the following phrase. So this is the phrase like he just mentioned in that paper in that workshop. So what he mentioned is every aspect of learning or any other characteristics of intelligence can in principle be described with such precision that the machines can be made to simulate it. So if you just go through that again, what he's saying is like any kind of intelligence that can be simulated with the machines. So that is what happening right now. And he said like we will try to discover how to make these machines use language from abstractions and concepts. And he also said like the tasks which are reserved for the humans right now will be will be this that those tasks will be done by the machines in the future. So if you see the present situation of AI, it is doing that one. If you take an example of self-driving cars uh, or any home or any smart homes, so where the human tasks where the tasks are reserved for humans, but now those are done by the machines or programs. So that is what the history of AI. And and let's learn about what is AI. So there is no perfect definition yet. Everyone has their own definitions. So, but all the definitions will say the same thing, like artificial intelligence or machines, or it can be a computer programs that learn to perform tasks that require a type of intelligence and that are usually performed by the humans. So that is what I just explained in the previous slide. The tasks which are reserved for the humans are done by the machines or the computer programs. Okay, we said like it learns to perform tasks that require a type of intelligence, right? So what is intelligence? So intelligence like we have many type of intelligences, like reading, a perceptron, or critical problem solving. We can talk. These are all called the type of different type of intelligence. So these AI machines will mimic that, or they just do the same thing what humans are doing right now. So that is what the high level definition of what is AI. So let's see the three different types of AI. The first type is artificial narrow intelligence, and the second artificial general intelligence, and the third is artificial super intelligence. So if you see what is artificial narrow intelligence, it also known as weak AI, which involves machines to perform only narrow defined set of specific tasks. That means AI can do only one task. It cannot do other tasks. So let's take an example of Google Assistant or Alexa or Siri. So these personal assistants cannot drive the car, right? Or a self-driving car, a self-driving program uh, cannot perform as a personal assistant. So these programs are narrow, which do only a specific task, which cannot do a multiple tasks. So that is what we say artificial narrow intelligence. And present AI is artificial narrow intelligence. We are yet to get into artificial general intelligence or super intelligence. So what is artificial general intelligence? Where the AI machines will be doing multiple tasks without any without involving the humans to make the decisions, where the AI will make their own decisions. Let's say artificial super intelligence. So what is it? Which involves machine will surpass the human beings. If you see the Transformers movie where the machines will control the humans, so that is what we can say like artificial super intelligence, but we are very far from that. Maybe it can take around next 50 to 100 years or less. Maybe we don't know what will happen according to the research in the industries. uh, it may take around 30 to 50 or 100 years to get into that positions. So we have four categories of AI, called reactive machines, limited memory machines, and theory of mind, and self awareness. So when we come into reactive machines, it doesn't have the past memory, and it cannot use any past information to process the future actions. So let's take an example of IBM Deep Blue, where the chess playing machine, uh, where uh, where it only captures the present situation of the board, and it will predict the future actions, but it cannot use the previous information. It just take the present situation, and it will do some calculations what can be the next steps, and it will perform in that way. So these are called the reactive machines. And now we have the limited memory machines, like that makes informed or improved decisions based on the past data from its memory. Self-driving cars can be an example. um, we have the limited memory machines right now, where it uses some past information to make the future decisions. And we have the next category called theory of mind. These type of AI should be able to understand people's emotions, belief, thoughts, and expectations, and can also interact socially. Like we are far from that one, but this is a different category of AI. And we have the other category called self-awareness, where AI that has its own consciousness or self-intelligence, which are self-awareness and sentient. In simple words, a complete human being. That is a different type of different category of AI, which are very far from achieving that one. So AI can be applied in different domains. So if you see, these are just a small number, but it can be applied to a number of domains. We can apply AI in business, in agriculture, healthcare, gaming, education, autonomous vehicles, social media, cybersecurity, and we can apply AI in many domains. So let's see some of the applications in all these domains, the mentioned domains. So let's say when we want to use AI in agriculture, like these are the different tasks where we can use AI. One, it can be agricultural robots, where we can also analyze the farm data to make the future predictions, or by just analyzing that, we can generate some insights where we can tackle that one. Uh, by just generating the insights, you can solve those problems. And we can also tackle the labor challenge in the agriculture field, or we can also monitor the crop and soil to improve the crop. And we can also use the air and pest and weed control or yield boosting algorithms. We have many of the yield boosting algorithms right now. And we can also create a personal assistant for farmer who can help in many things, how a farmer can uh, take decisions in his crop. So a personal assistant can help in that, and we have many more applications in agriculture. When we come into AI in banking and finance, we use almost all the machine learning algorithms for trading purpose here. We'll try to predict the future outcomes based on the complete past data, let's say time series data. Mostly we can say that. And in most of the banking or finance websites, you can see the chatbots where it will talk with you, or it will do some routine tasks which are asked by the humans. And we can also use AI in fraud detection or customer recommendations in banking or finance. And we can also use AI to automate the credit scoring and load process. Most of the banks are doing this one, like automating the credit scoring. And it will that systems will define whether you will be getting the loan or not. And we can also use that in the risk management, and we also have many applications for that. So when we come into AI in healthcare, we can use AI like in drug discovery or virtual nurses and doctors. We can see this one happening in many hospitals right now. And we can also remote monitoring of patients. I think you have seen the news, like in many hospitals they are using robots to go near the COVID patients. So you can see how AI in healthcare is improving. And we can also do the robotic surgeries. Many hospitals are testing that right now. And we can also do personalized treatment based on his previous data, and clinical train research, or improved radiotherapy, and etc. We have many more other applications. When we come into AI in gaming, so we have many places where we'll be using AI, where we will be generating generation of characters. I mean, we can use GANs here, where we can generate new faces or new avatars. We don't need people who will just do some drawings and create their characters. We can use AI, which is not perfect, but maybe in future we can see AI is generating the new avatars in the games. Or we can also create maps or levels using AI. And we can also improve the gaming experience of the users. And we can also predict human players behavior. I think when I was just playing shadow fight recently, so in that it is saying that your opponent is learning from your moves. So you can imagine how AI is used in the gaming. It is learning our moves, and the opponent is playing a crucial role, like he is learning and he will try to defend the same moves which we will be using. So we can use AI there. And we can also use fraud detection, like PUBG is using that one to detect the bots and to detect the players who are cheating. uh, and we have many more applications there in AI in gaming. And when we come to AI in education, this is where AI is improving a lot these days in this situation of COVID, in these COVID situations, where it is additionally supporting AI tutors. Like we will be having AI tutors who can solve the queries of the students when the real faculty is not available. And we can use AI in generating the smart content and virtual facilitators and learning environments. And we can also simplify administrative tasks like grading. We can see this using AI in grading in many websites actually. And we can also generate the personalized learning based on what he learned previously. And we can predict the career path of those students based on what he is learning these days. what are the courses he have taken, what are the videos he has watched, and we can generate the a good career path for them. And we can also use AI for generating the feedbacks and learning from the feedbacks of the students, and we can improve the environment of that smart education. And if we want to use AI in automotive industry, there are many applications here as well: driving features, self-driving cars, or cloud services using AI, automotive insurance, car manufacturing, and driver monitoring. We are seeing these applications these days, and we have many other applications as well. Um, when we come into AI and cyber security, uh, this is where AI is also improving these days. It is improving every day in the cyber security domain, where we can use AI like detecting the network intrusion and preventing that, and fraud detection. We can also detect botnets. We can also detect whether the hacking incident is happening or not, based on the packet, based on analyzing the packets, based on analyzing the network behavior and everything. We can detect whether a hacking incident is happening or not. And we can use AI, smart filtering, or we can use AI for detecting vulnerabilities in the software, and privacy protection as well, and many other applications in cybersecurity. And what can be the future applications of AI? So AI can be both. Like it can be a good or it can be a bad. But when we come into good, we can see these kind of applications in the future, like completely automated transportation, where we can reduce the number of accidents. Um, because all the cars or all the vehicles will be talking to each other, so there will be less prone to the less number of accidents in the future. Or we can, like, humans augment themselves with the robots. Let's say if you have seen the Neuralink, where the Elon Musk is using some chip inside the brain of a humans. So maybe we can use that technology to you can just sit on the couch and let's say, okay, bring me the water inside your brain. Or else you can say, I need to drink water right now. So the robot will understand and robot will get the water for you. So that can happen. I don't know, but that can happen maybe. And we can also see smart cities in the future. That's for sure, we can see that. And we can see the robots help the elderly people. This is very important. If there are no persons to take care of the elderly people, maybe robots can take care of them. And we can automate the hazardous jobs like coal mining, or people ski waste mining, or ski waste cleaning, or whatever, which jobs are very harmful to the humans, that can be automated through using robots. And we can see many more applications like this, or more advancements in the same applications which I mentioned right now. So these can be the very good future applications of AI. Yeah, and that's it, the application side. We can see AI in many domains. Whenever you want to apply AI in a domain which you are interested in, you can just search about that one, and you'll be getting many examples where AI can be used. So we learn about AI, but how can we achieve AI? There are many ways to achieve AI. We can use machine learning, or we can use NLP, expert systems, or vision, or we can use speech, planning, and robotics. We can use any of these to achieve AI. But in this session, we'll be focusing on machine learning, where we will use machine learning to achieve AI. So that is what we will be doing. And yeah, thank you. We will be just giving some time, like I'll just give some time to ask you questions. If you don't have any questions, then we can move forward for the next one. What is machine learning? So if you have any questions, you can ask, or else we can just move forward. Okay, great. If you don't have any questions, uh, we can just move forward with this one. We'll learn about machine learning here. So what exactly is machine learning? So we learned about AI and we are using machine learning to achieve AI. So what is machine learning? So let's see the definition. Like machine learning is a subset of AI which mainly focus on machines, and which those machines learn from their experience to improve their performance, and making predictions based on its experience, making predictions based on its experience. So let's just see these two types of programming, and we can understand how machine learning is different from the traditional programming. So if you come to the traditional programming, where you will be using the data and you'll also give the program, or let's say rules. So where you give the data, you give the rules, and computer will generate the output based on the rules. But in machine learning, it is different, where you will give the data, you will give the output to a program, and it will generate the rules, or it will generate the program. So it uses the data, it uses the output, and it will generate the program. So by using those program or those rules, we can predict the future outcomes. So that is what we can say, like machine learning, learning from their experience. So learning from the data, that is what its experience, and it improves through performance. Like we will use multiple algorithms which tries that machine learning will get improved based on the previous experience and making predictions. So it will predict the future outcomes based on the past data. So that is what the high level overview of the machine learning. So you'll understand more about it in the future slide, in the next slides. So what does machine learning do? What exactly it do? So it enables the computers or machines to make data driven decisions rather than being explicitly programmed for carrying out the certain task. So I'll just explain this in a simple terms. So previously we used to have expert systems where we will be writing many rules. Like you have some data and you will be writing rules. Okay, if you want to get this as an outcome, you need to pass all these rules. Let's say multiple if conditions. So if this is happening, this should happen. If this is happening, the other thing should happen. So in that way we used to have multiple rules, multiple if conditions, or multiple rules to generate the output. So in expert system, we use it to write those rules. But when you come to machine learning, we don't need to explicitly write the rules. That program will generate the rules using the data, which can be used to make the decisions in the future predictions. So that is what the outline of machine learning, where you will not explicitly program it. It will write its own rules based on the data. It will generate the patterns actually. To be frank, it will generate the patterns. Let's say these programs or algorithms are designed in a way that they learn and improve over time when are exposed to the new data. So let's say you are making some predictions based on the past data, or let's say let's take an example like let's take an example of this one, the simple example where we will be predicting the price of a house. So let's say uh, you guys are in Delhi right now. So in Delhi we want to sell a plot. So we will look at the past data, like how people, like how much the cost, how much we can sell that plot for. You'll just go through all the previous data, previous year's data, and you'll make a decision. Okay, this plot can be sold for this price, and you will do that one, or based on the number of features, like the plot size, or like whether it is near to the main road, or it is near to the highway, or it is in city, or it is in village, or based on all these features, uh, you'll make a decision. So in that way machines will do the same thing. It will take all the data and it will generate the output for you without making any rules and everything. It will generate its own rules. So in simple terms, it finds the patterns in the data. So that is what we discussed right now. Okay, then why we need machine learning? Why can't we use the traditional programming for all these things? So not everything can be coded explicitly. So as I said, if you have a if you, do anyone write thousands of rules? No, right? If you want to change something, you need to add multiple rules in that thousands or 10,000 lines of program. So no one will do that one. So instead of that, we can use machine learning here. Or even if we had a good idea about how to do it, the program might become really complicated. So um, let's take an example of self-driving cars. So you'll be if you want to write a traditional program for that one, you need to write multiple if conditions. Okay, if there is a vehicle beside you, you need to go slow, or if there is a vehicle ahead of you, you need to slow down. These kind of rules you need to write. But whenever some accident happen, you will understand, okay, we need to add a different rule again. So instead of making that accident happen, why don't we use machine learning here? So that is the other reason we can use machine learning. And scalability, ability to perform in large amounts of information. If you have a large amounts of information, humans cannot process that one, but machines can process that one. So this is where we will use machine learning again. So these are the use cases where we need to use machine learning. So but we have machine learning from 1960 or 1970. But why now we are using that one? Machine learning need a lot of data, and lot of data is available right now. Machine learning need a lot of computational power, and we have a computational power right now. It is increasing day by day, and we need more advanced algorithms. Advanced algorithms are available, and we have a lot of increasing support from industries like, let's say, the companies like Google, Nvidia, Facebook, Microsoft, which are generating new algorithms or new computational hardware and everything. So from all these support, they also doing a lot of research to generate the new algorithms. So with all these support, uh, now machine learning is becoming very, everywhere we are using that one. So these are the reasons why machine learning is famous right now, and which is hype right now as well. So when to use machine learning? Do we need to use machine learning every time? No. There are cases where we don't need to use machine learning at all, but there are cases where we need to use machine learning. So when a problem is complex and can't be solved with a traditional programming method, we will be using machine learning there. As I explained with the self-driving example, where we cannot write multiple if conditions again and again, so we can use machine learning there. And where human experts does not exist, so when we so the Mars rover, right? uh, which is uh, which is by NASA. So there are no humans there to navigate that one. It should move on its own, based on the conditions, uh, based on the surface it has. So we can use machine learning there, and humans can't explain their expertise. So let's take an example of speech recognition data. Let's take speech data. If we just speak for 1 second, we have around 44,000 of samples, where human cannot go through that one and explain what is happening in that 44,000 data points. So it is difficult for a human to go through. So instead of that, we can use machine learning there. And when we want to make a personalized shopping, then we need to use machine learning there. We cannot assign a single human for multiple customers, right? Okay, generate the personalized items for him. A human cannot do that one, but machines can do that one. And models which are based on huge amounts of data, like genomics, like genomes, where human cannot go through that data, because we have lot amount of data. Let's say I don't remember the number, but 1 gram of DNA consists of some amount of TB, actually TB of data. So humans cannot process that one, so machines can do that one again. And you don't need to use machine learning where learning is not required at all, like calculating payroll, where you don't need to learn from the previous data. You can just do that one by yourself. So we don't need to use machine learning in the situations where learning is not required. Okay, we and now we can see the applications of machine learning. These are like small number. There are tens or hundreds, thousands of applications available on internet right now. So these are just a few number like virtual personal assistant, predictions while computing, video surveillance, social media services, email spam and malware filtering, or online customer support like chatbots, search engines, and personalizations and fraud detection. So these are a small number of applications of machine learning. There are n number of applications available. And okay, we talked about learning from the learning from the experience. But what is that learning? We have four types of learning: supervised learning, unsupervised learning, and semi-supervised learning. And we also have the reinforcement learning. So what is supervised learning here? Training data includes desired outputs. Unsupervised the training data does not include the desired outputs. And in semi-supervised learning, training data includes a few desired outputs, and in reinforcement learning, rewards from sequence of actions. Okay, I'll go through all these in detail, so you'll learn more about that one. So let's just see what is supervised learning here. In supervised learning, what we said is we have an input and we also have the output for that one. So we'll be having the data in this format where you'll have an input x1, you also have a output y1. So input x2, output y2, and so on. You'll be having data in that format. And the goal of supervised learning is to find an unknown function which maps the relationship between input and output. So let's say we have an input and we have an output. So we want to find a function which defines when we give some input how it is generating the output. So we want to define this function. What is that function? What is the underlying function between the relationship between these two? So in machine learning, we cannot define the function 100%. So what we will be doing is like we will be approximating the function. So we cannot find the exact underlying function. So we will try to approximate it. So you'll understand the word approximation here. So let's say y equal to the output equal to some function plus some error, and we want to find that function. What is that function given and some input? So we'll be using the input data and then we generate a function. Let's say let's what I like I said approximation function which maps the input and output. So we have two types of supervised learning here. One is regression and the other one is classification. So regression is nothing but the output variable is a continuous numerical value. It can be anything. You can just give some input and it will generate some output value. So when we come to classification, these are like discrete. So we have limited number of output values. So let's take an example like Titanic example, where you'll just give the data and you will predict whether that person is alive or not. So only you have only two outputs here, whether the person is alive or whether the person is not alive. So these problems comes under classification, where you will be classifying an input, whether that person is alive or not. So that is one example for classification. And regression, you can say the house price prediction, where you will be just giving some data and you'll predicting the price for that one. So that comes under regression. And these two are types of different types of learning in supervised learning. Okay, now when we come into unsupervised learning, where we'll be having only input, we don't have any output data. We just have some input. We need to find some patterns from that input data. So the goal of unsupervised learning is to model the underlying structure or hidden structure or distribution in the data in order to learn more about the data. So you'll just give the data. The unsupervised learning algorithms will try to find the underlying pattern in that data. And here algorithms are left to their devices to discover and present the interesting structure in that data. So that is what I said, like you just give the data, it will find the underlying pattern in that, to find some interesting insights or find the interesting patterns in that data. And we have two types of unsupervised learning algorithms, clustering and association. So clustering is nothing but you just give some data, it will find clusters of that data. So let's say you just given the uh, 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 a group of people data from a shopping, let's say Amazon. You'll just give a group of people data from the Amazon's website, and you want to find the different cluster of people who have the similar behavior. So you can use clustering techniques where it can group the people which have the similar behavior. And we have other type of learning called association, like which is hard to explain, so I'm skipping that one. And we have a semi supervised learning, which is another different type of learning. So what it is like, it is in between the supervised and unsupervised learning. So mostly we will have a combination of labeled and the unlabeled data here. So we will so what we will be doing is like, you can use unsupervised learning to discover and learn the structure in the input data. So we can also use the supervised learning algorithms to learn the underlying function, and then predicting the output of the unlabeled data. So that is what we mostly say transfer learning in nowadays. So where we'll be using transfer learning, so to learn the underlying structure of the data, and then we'll make the predictions uh, for the data which is not labeled. So that is what we can say transfer learning or classic algorithm techniques, and feed them back to the supervised learning algorithm to improve the performance. So that is what comes under semi supervised learning. So we learned about everything. We learned about machine learning and different types of learning. So but how machine learning works exactly? So these ML algorithms are described as a learning the target function. So as I said, there will be a natural function which maps the relationship between the input and output. So we will be using some algorithms to learn so that underlying function. So that can be let's say f of x. And here the function f, which maps the relationship between input and output, is generally unknown. So we will be estimating that one based on the data we have. And we will be doing that, or we'll be estimating that function in two ways. One can be a parametric methods and the other can be non-parametric methods. So in simple way, like what is parametric methods? A model that summarizes the data with a set of parameters of fixed size. So let's take an example. Let's take the same example where we just use as example like house price prediction. So we have some features there. So the size of the plot, and whether it is near to the highway or not, whether it is a city or in village. We have different features here. So we'll be having some equation where you will just do the input data, and for each input feature we will be having a coefficient for every feature. So that is what we say parameters. So these parameters are fixed for few algorithms. So let's say we are using these algorithms called linear regression, logistic regression, or SVM, so simple neural networks. So where we will be having a fixed number of parameters, and these parameters will not change given the same data. So, so as you can see, like no matter how much data you throw, it does not change its mind. The parameters never change. The parameter size will be the same. And these are the example algorithms for parametric methods. And what are the advantages of parametric methods? These are very simple because these methods are easier to understand and interpret because the algorithm is fixed. So it will not change at all. So it is easier to understand, and these algorithms are very simple, which can be easily interpreted. And these algorithms are very fast because it knows what to do, so it will be very fast. And these algorithms will also work well with less data as well. We don't need a high amount of data, when where we can have very less data, and it will work perfectly. And what are the disadvantages of these parametric methods? These parametric methods are constrained because the algorithm is fixed. We can the algorithm cannot be changed. So you can see by choosing a function form, these methods are highly constrained to the specified form. So if you take a linear regression which is linear, we can change that one. So we are constrained for that. We are constrained with that form, linear form, and that is one of the disadvantages of parametric methods. And these are limited complex. These methods are more suited to simpler forms. If we take if we have seen some algorithms which are completely linear, because these are applied only for linear data. We cannot apply those for the non-linear data. So there is a limited complexity here, and which are poor fit, because we don't know what is the underlying mapping function. So when we just apply a linear to every kind of data, it will definitely poor fit. It cannot fit that non-linear data. So these are the biggest disadvantages of the parametric methods. So when we come to non-parametric methods, here uh, we have a lot of data and we have no prior knowledge about the data. So you'll just apply the algorithms, and it will find the patterns from that data. We don't have any fixed number of parameters here, so it can just go to any level. It can improve its complexity to fit the data, or it can decrease the complexity to fit the data again. So this is a very good advantage of that one. So number of parameters is infinite here, and the complexity of the model grows with the increase in the training data. So when you increase the training data, the complexity of the model also increases. So let's take an example: algorithms like k-nearest neighbors or decision trees or kernel SVM. So these are the example algorithms for non-parametric methods. And what are the advantages of non-parametric methods? So one of the advantages is the flexibility. So as I said, in the parametric methods, which is very less flexible because the form is fixed. But here, when we come to non-parametric methods, the form is not fixed. The capability of fitting many functional forms. It can fix to it can find any mathematical equational form, anything. And when it comes to power, we don't assume anything about the underlying functions. So let's say when you come to uh, parametric methods, you assume something. What are the assumptions for parametric methods? Let's take an algorithm, linear regression. So there is one assumption for linear regression is the data should be linear. And when we come to uh, non-kernel SVM, it also assumes that the linear should be sorry the data should be linear, the function should be linear. But when we come to non-parametric methods, we don't have any assumptions about the underlying function. This is one of the biggest advantages of non-parametric methods. And and when we come to performance, it can have a high performance because it can find any underlying pattern. Instead of just finding instead of fixing to some form, it can find any kind of underlying pattern. So the performance will be very high when compared to parametric methods. And what are the disadvantages of non-parametric methods? One of the disadvantages is that it requires more data to understand understand the underlying function of that data. So when we give more data, the performance will increase more and more. And another disadvantage is like it is slower to train because because we don't have any fixed parameters. It just increases based on the data. So it will take more time to train the algorithm. And we have the other disadvantage like overfitting. So most of the non-parametric methods tends to overfit to the data. uh, I think I can explain, but it will be hard to understand what is overfitting. For this session, we'll just skip that one. Maybe in the future sessions, we can learn more in depth about all these terms. Overfitting is nothing but it will completely fit to the data, where it will not work perfectly uh, with the data which is not trained on. So that is what we can say overfitting. And what are the different components of machine learning? So there are three components for machine learning. So one is representation, the second one is optimization, third one is evaluation. Representation is nothing but the algorithms. When we come to optimization, we will be optimizing those algorithms to fit to the data and find the uh, underlying function. That is what optimization. And the third one is the evaluation. So we will be evaluating how well the optimized model performing on the data. So these are the three components, and we have another thing called loss function, which is very important in machine learning. These loss functions are very important. And let's say, what is the loss function exactly? Okay, these are the methods which are used to evaluate how well your algorithm models your data set. So you can understand how important loss functions are. And if your model fits perfectly, you will be having a very less loss function. If your model is poor, your loss function value will be very high, and vice versa. And if you make any changes to the algorithm, loss function will help you to say where you are going. So based on, if you change something, your loss function will say whether your change is good or not. If you make some changes, your loss function value is high, so it says okay, your changes are not good. You made some changes, your loss function value is low, so it will say okay, okay, your changes are good, your function is working as expected. So it helps, loss function helps in that way. And we use optimization functions like gradient descent. So I'll not go through the gradient descents because it needs a lot of time to explain that in detail. So we'll be doing that in the future sessions. So these optimization functions, what optimization functions will be doing is, as we learned, like we'll be having parameters which are fixed in parametric and which are infinite in non-parametric methods. So we need to find these parameters. So how we will be finding them? So we will be using gradient descent to find those parameters. uh, and these optimization functions like gradient descent, which helps loss functions to learn to reduce the error in predictions. So in this way, the machine learning algorithms work. You'll be give data, you'll take some algorithm, you'll apply optimization functions, it will generate some loss. So based on that loss, this gradient descent learns okay what need to be improved, and it will improve the it will improve the some function, underlying function, and that model will learn from that one. So in this way it works. I think I need to explain what is gradient descent in detail. You'll be understanding this one. Okay, we have like different loss functions for different type of problems. So when we come to into regression, we have mean squared error or mean absolute error. When we come to classification problems, we have hinge loss or log loss. So these are the different loss functions. We also have many loss functions for clustering or association. So you can find what are the available loss functions. You can find them on my Instagram page, or you can just go through on internet. You can just directly search there. Okay, and that's it for like uh, what is machine learning. Like you understand, I think you learned something from these slides. So I'll just give some time to ask your questions. If not, we can just directly go through the next thing, where you'll be learning about how to get started and what are the different career opportunities available. So if you have any questions, you can just ask me. So I'll go through the comments and I can answer your questions. Okay, there is one question like I hear XGBoost is the best algorithm for solving classification problems. Is this true? Yes, we can say XGBoost is one of the best algorithm. Um, because what it will be doing is it will take the low I think it will take the um, high bias and low variance models, and then it will try to improve the bias. Like it will learn and improve the bias in the algorithms. So so we can say it is one of the best, because it will learn from its mistakes. So let's say you applied some algorithm on the data. That algorithm will be having high bias and low variance. That means it is underfitting. First thing, it will not perfectly fit to the data. So it will make some predictions, and based on that predictions it will learn. It uses those predictions, and it will do some calculations between the real output and the generated output, and it will again apply the new algorithm on the generated output. So we will eventually, it tries to reduce the bias in the algorithms, so reducing that underfit, and it will try to balance between the bias and variance. So that is where uh, XGBoost works in that way, and which works very well. I hope I answered your question. If you want to learn more about XGBoost, or if you want to learn more about that one, I can send you the resources for that one. You can just directly ping me somewhere. And we have some question, other question, like, can you send the presentation used? You can find all these presentations. So, okay, I'll give the link where you can find all the presentations. All these presentations are available on internet right now. So at the end of the session, I'll just give the link. You can just directly go there, and you can find all these three slides. Okay, I think there are no more questions. So can we can start this one. Okay, I think the most awaited thing, how to get started with machine learning. So we have multiple steps here, like how to get started with one. So let's go through all the steps. So we have the step one, where you need to have the right mindset. If you just sit and think, like, do you really need to get into this field? Why you want to get into this field? So what made you to think about machine learning or artificial intelligence? So without having the right mindset, you cannot pursue, or you cannot completely go through in this field. So there are two things actually. One is you're really interested, and the second one is um, you're interested in this field because of the hype. So if you are really interested in this field because of the hype, then this is not the right career path for you. So if you're really interested to pursue in this field, then you're a right person to get into this field. Because there is a because in this field, it is like continuous learning process. You need to continuously learn every day, because you'll be getting new algorithms. We are getting new algorithms every day and every day. A lot of research is happening, and a lot of the models are improving every day. So you need to promise yourself that you will learn every day for at least 30 to 1 hour, 30 minutes to 1 hour. So first step is having the right mindset. So if you have a right mindset, then you are in for this field. And step two, choose the right path. There are two types of paths where you can just where you can follow any of the path to be in this field. So one is a top down approach, and the other one is bottom up approach. So I'll go through these two in the next slides. So this is a step two, you need to choose the right path. And in the step three, choose the right tool. So if you are interested in learning Python, or let's say R, choose the right one which suits you, or which the job needs. So if you are in a field it needs Python, you need to learn Python. If you are in a field which needs R, you need to learn R. So it is very important to choose the right tool. So that is step 3. And step 4 is practice and practice. You need to practice a lot, where you'll be learning every day. If you just learn the theory and you just leave that one, then you're not the right one to be in this field. So you need to practice a lot. You learn something, go and practice that on the available data sets. There are a lot of websites like Kaggle, or you can just go. Google recently launched a data set search engine. So yeah, where you can just go to that and just type something, just type Titanic data set or house price prediction or cancer data set, whatever. You'll be getting a lot of data sets. Take that, take any one of them and practice what you learn. So that is what you need to do every day. Practice and practice. And step 5 is to build a portfolio. So, building a portfolio is very important in any field. It can be in any field. Portfolio is very important. So, because of this portfolio, you can showcase yourself to the industry. So, let's say you are a computer science guy, and you want to showcase yourself. So, how you will be showcasing yourself? You can showcase through projects, or uh, you can showcase through the blogs you have written, or you can showcase the YouTube videos if you made any. So you can showcase in any self, in any way, like YouTube videos, books, or articles, or you can start an Instagram page or LinkedIn page, where you write something like completely a content creator. So in that way you can showcase yourself, or you can post whatever you can. If you can keep whatever you are doing on GitHub. So people, like companies, will usually ask what is your GitHub URL. So whatever you do, post that on GitHub, and people will get to know, okay, you are doing something, you are doing all these things. So it will help you to get a good job or internship, or whatever the recognition you're looking for. So that is the step 5. And if you follow all these steps, then you are good to go actually. So as I said, in step 2, we have two types of approaches. Like one is top down approach, and the second one is bottom up approach. So what is a top down approach? So in top down approach, so the first step is where you will be where you will learn the high level process of applied machine learning. So if you take some project, you'll be learning about only that project. So let's say if you're learning something about object detection, so you learn first about the object detection, or directly what you will be doing is like you'll take a data set and apply the available object detection algorithms on that. So that is the first step. And then you learn about the tool, whatever the tool you are using, you learn more enough about that tool, and you'll be using that tool to complete the project what you are doing. And you can as a next step, you can practice on data sets a lot. You can, as I said, you can take any data set and practice what you learn. And then, and the last step, where you will be learning the theoretical concepts in the fourth step, when you come in a top down approach. So you'll be taking a project, you'll be learning about that one, you'll be applying that one, and then you'll be learning the underlying concepts of that project in a top down approach. But when we come to bottom up approach, uh, sorry, the slide has the same name, but it is a bottom up approach. So in this way, you will be completely going from scratch. So where you will first learn all the prerequisites like programming and math, and then you will be learning machine learning in depth, and then you will be applying those concepts what you learn, and then you will be building the high level systems for end to end process. So this is one way where you will start from the scratch. Like first you'll learn the prerequisites, and then machine learning, and then you practice, and then you build the high level systems. So if you ask anyone, everyone will suggest only the bottom up approach, because that is the best one instead of going from a top down approach. So if you ask me, I'll also suggest the bottom up approach, because I followed that one. So I can say it is the best one. And what are the math prerequisites for this one? So these are the four things which is very important as a math prerequisites. One is calculus, one is linear algebra, probability, and statistics. So in calculus, you don't need to panic. Like you just only need to learn the differential calculus and the chain rule. We will be using calculus only in only one place where we are doing the optimization thing, where we are finding the parameters. So we'll be using calculus there, and linear algebra. Basics of linear algebra is enough, and we have a probability and statistics. In statistics, you need to learn the inferential and descriptive statistics. So why we really need the math? So as I explained, where calculus is important, it is during the optimizations. It is during finding the exact parameters in the model. So there we will be using calculus. But why probability? Where we are using the probability? If you see, machine learning is about developing predictive models from uncertain data. So what is uncertainty? Uncertainty means working with imperfect or incomplete information. So this is where we will be using probability. These are three main sources of uncertainty in machine learning. Uh, what are those? Like noise data, incomplete coverage of the problem domain, and imperfect models. So these are the three main sources of uncertainty. So as a machine learning practitioner, we must have the understanding of probability in order to manage the uncertainty we see in the each project. So this is where the probability is very important, managing the uncertainty. And why we need statistics here? So statistical methods are required to find answers to the questions that we have about data, or to understand the data, use it to train a machine learning model, and to interpret the results of testing different machine learning models, where we will be using the statistical methods. And each step in the predictive modeling project will require a use of statistical methods, because every machine learning algorithm has an underlying statistics. So that is where we will be using the statistics. And why linear algebra? We use linear algebra everywhere in machine learning. A lot of concepts like ML concepts are tied up with linear algebra. To understand the notations in books, help us to read and interpret the statistical concepts, or helps to understand PCA, which is dimensionality reduction algorithm. So yeah, we'll be using linear algebra here. And when you want to start a project, I mean, it has multiple steps while starting a project. I'll not go through all this one. I think it's really boring for everyone. So I'll just give the high level overviews. Like um, as a first step, what it will be as a first step, you will define a business problem, and you'll be gathering the data. And the next step, what you will be doing is like data cleaning and formatting. And the next step, you'll be exploratory data analysis. You will be finding the insights from the data, or you will be finding some important things from the data. So that is where you'll be using exploratory data analysis. And the next step, you'll be using a feature engineering and selection. I mean, you can learn all these things. I'll just give the slides. So I'm not going through all the sentences here. So, so next step is the feature engineering and selection, where you will be having the a garbage data. Let's say in machine learning, we have one thing: garbage in, garbage out. So when we give a garbage data, you'll be getting the garbage output. So instead of that one, so what you will be doing, like you'll be applying some feature engineering and selection. So you'll be selecting some features, or uh, you'll be doing some kind of operations to generate some good features from that garbage data. And as a next step, you'll be applying machine learning algorithms, or multiple machine learning algorithms, and you'll be comparing them. And then you'll perform some hyperparameter tuning. So there are two types of parameters. So which are some parameters we need to tune them, and some parameters which are fixed. So you'll be doing hyperparameter tuning as a next step, and then you'll be evaluating the models, how well your models are performing. If it is not performing, you'll just go back to all the steps again. And the next step will be, after getting the model which gives the good which let's say you are expecting something, some output, and if your model is giving that output, then you are satisfied with that one. So and then and at that place, what you will be doing is you'll be deploying the model, and then finally you will draw the conclusions and document the work. So these are the project steps where you need to follow to have a good model for you. And the last thing is like you need to practice a lot. As I said before, you need to practice a lot. So whenever you ask me, I'll say this one: practice, practice, and practice. Then only you will understand the concepts, and you will understand what to do when you have a data in your hands. So if you practice well, you'll do that one. And finally, this is the final topic for this session. What are the different career paths in machine learning? So the first career path, let's say, as a machine learning engineer. So what you will be doing in this machine learning as a machine learning engineer. So these are the roles and responsibilities where machine learning engineers are primarily involved with the designs and developments of the ML systems and applications by using ML algorithms and tools. And as a next, and they also do like they also conduct and run various ML experiments. And these are the skills required for machine learning engineer, where you need to good at mathematics, statistics, programming, software architecture, system design, and data structures and data modeling, and ML algorithms. So these are the skills for machine learning engineer. And when you want to be a data scientist, so these are the roles and responsibilities of the data scientist. uh, I mean, data scientists also need to be have a machine learning skills, where you will be gathering data from different touch points, analyzing and interpreting it, and drawing insights and inferences. And these are used to make business decisions by the company executives as a data scientist. And these are the skills required for data scientists. And when you come to data analyst, the roles and responsibilities of data analyst are like transform and manipulate large data sets to suit the desired analysis. This role can also include tracking web analytics and analyzing A/B testing. And these are the skills for a data analyst. So I'm not just going through anything. Like you can just learn what are the roles and responsibilities and skills for a data analyst. In the other role, we have data engineers. Data engineers are very important for a project or for a company, where they will completely manage the ETL pipelines, the data pipelines, let's say, where the data need to come from, or what operations we need to perform on data, and where the data should be stored. All everything will be comes under ETL pipelines, and the data engineers will take care of that one. And we have another role called a business intelligence analyst, so where they will completely focus on the analyzing and checking the performance of business KPIs and improve its company's competitive positioning. And they also identify the issues and best practices for that, and they also create exceptional graphs and dashboards to communicate the insights with the business team or the company executives. So that is what the roles and responsibilities of BI analyst. And we also have other there are many other roles in this domain, but the things which I had shown are the famous one, I mean most which are very important for the project. And these are the other roles which are also important for a company or for a project, uh, which includes data architect, database administrator. We also need statistician and data analytics manager, and we also have data warehouse architect or research scientist, and there are many roles. um, let's say NLP scientist or computer vision scientist. Depends on the company. So let's say if you are going to for a startup where you don't have these many roles, only 2 to 3 people will manage all these roles in a startups. When you go into mid-sized companies, where you'll be having multiple people doing all these roles, or when you just go into big companies, very big MNCs, you'll be seeing one person available for one role. So that is what happens in different size companies. And yeah, and that's it for this session. I hope you learned something, and thank you so much uh, for being thank you so much for being patiently and learning everything. And if you have any questions, please ask me. Or if you don't have any questions, we can just sign off. And I'm really thankful to the students developer students club VVP college, uh, for giving me this opportunity to provide some knowledge to the students who are interested in getting started in machine learning, and checking what are the different available opportunities for them, and also learning about the artificial intelligence and its applications, and machine learning and bit of machine learning. So if everyone loves what I'm doing, so if you think you need some more sessions from my side, I'm very much interested to doing that one. We can do some project demos in the future if you guys are interested in learning again. So, and yeah, thank you so much everyone, and if you have any questions, please let me know.